Hello, welcome to this tutorial series. Today we are going to look into a problem called a snake and ladder. We might have played this game in our childhood, but today we are going to come up with a design for this snake and ladder. This is a board game. This board usually will be in rectangular in size. It might have defined positions. It might start from 0, it might end at 108, it might end with 100, whatever may be the case. Each player will throw a dice based on the value which comes out of the dice. The player will move their position to the appropriate value. So that is how the each player will move towards the destination, which is the end, which is the top end. So let us look into the requirements very clearly. The board can be of any size. It means that uh, the board size is not fixed at the time of the game or the complexity of the game. Each game may be the board sizes may vary from a smaller game to a bigger game. That's what we can think of, and that is given in the requirement. Each player puts their counter at the start of the position. So assume like the game starts at 0. This is the requirement. uh, each player takes their own turn to roll their dice. Each player gets a fair chance of throwing their dice and moving forward. That is also a requirement. uh, when the dice is thrown, the player's position moves forward by the face value of the dice. What is on the outcome of the dice, value of the dice, the player moves forward. That is also given in the requirement. So what is the role of this snake and ladder? This is what we are going to uh, do it now, and that is given the requirement. When the player lands on the head of the snake, for example, if somebody rolls number somebody is in number position 65 and they have rolled their dice, and the outcome is 65 plus 5, which is going to land them in 70. On the 70th position, assume like if this snake's head is hit, they will come back to the tail of the snake. This is a requirement. Whenever the player's new position moves towards the head of the snake, they will fall down to the tail of the snake. Whenever the new position goes to the tail or the bottom end of the ladder, they will go to the top end of the ladder. This is the requirement. So a ladder will whenever the new position goes to the ladder, the player will climb up to the end of the ladder. Whenever they hit the snake, it will has to come down. So they keep rolling the dice till they reach the end position. And the requirement is given in such a way that there will be it is a multiplayer game. It is not a one player game, although it can be customized to a single player game as well, right? So how long the players can play, that is also given in the requirement, or we can talk and understand how long the player can play. Assume like if 5 players are playing, a player state has to be maintained, and there are two options. We can proceed with the game till one player wins, or till we are left with only 2 players. These are the two outcomes that we can play for. So we can clarify this requirement. We can clarify this requirement at the start of the coding. So now how I have coded is, I have coded this program or this snake and ladder game in such a way that till the last 2 players are available, they keep rolling their dice and then they play. There is also an end condition. Assume if the player is in position 99 and 100 being the last position in the game, if the player throws the outcome of the roll of the die is more than 1, for example 99 plus 1 equal to 100, the player remains in the same place. So the winning strategy is they have to reach the last position in the board. It's not that they cannot cross the last position in the road in the board. So that is also given unstated in the requirement. Now with the requirements being clear, Let us go and look into the coding part of it. So this let's look into the models. Uh, so the dice is used to move, right? The players throw dice. So the dice, when we think about it, that is minimum requirement for a game to start. So each dice will have a min value and a max value. For example, assume a dice will have 1, 2, 3, 4, 5, 6 as their face values. So we are saying it has a minimum value and maximum value. And the dice also will have the current value. What is current value? Current value is the outcome of the throw. So we are only maintaining these three properties. Why we are not maintaining those interim values like 1, 2, 3, 4, 5, 6? We can always assume that the values are increasing and sequential, so we need not maintain those values. And a dice will have a method called roll, and I am using whenever we roll a die, I'm using a random number simulator to get the next value starting from the min value to the max value. Why did I use max value plus 1? Because min value is inclusive, max value is exclusive. It means that min value is inclusive means if the position starts from 1, and if we say 6, we will always generate random numbers between 1 and less than 6. So we need a number inclusive of 6. So I am stating that 1 into 1 and 6 plus 1, which is 7. So we are going to get the value between 1 and 6 by this time. This we have to be very careful. Next thing is player. So at any point of time, player only plays using dice. So let us revisit the player. If we take the dice, we only have the getter and all are constructor, because the min value and the max value are initialized at the start of the at the start of initialization of the dice. So the min value and max value should not change. Only the current value is the outcome, which also is a getter. There is no setter. Nobody sets the current value. We have to be very clear with getters and setters here. You cannot put setter for we cannot use setters for all dice for dice. Let's look into the player. Each player will have a name, or whatever, we can have an ID as well. I've used a name. It means that a player's name are assumed to be unique, or they have to choose a unique player name. We have there are only mutable certain mutable fields for the player. Assume for dice there are no mutable fields. With no mutable fields, nobody can set values from to the die from outside. And similarly, player also will not have all mutable fields. The name is set at the start of the game, so people will not be able to change the name. So the player's current position is a mutable field, because as and when we throw the dice or roll the dice, the position has to be changed. So that is the one setter field that I have. The other thing is whether the player has won or not. As the player rolls the dice, the position changes, and if the position reaches the end of the board, the player has won. So that is a mutable field here. Rest all are immutable fields. Let us look into the constructor here. So the player is initialized with a name. We are initializing the name. Each player starts with position 0. As we initialize a player, the player will start with the position 0. By default, the player has not won. So at the start of the game, it is initialized to false. So this constructor is also very important. So while we design this snake and ladder game, let us pay careful attention towards the getter, setter, and the constructors as well. These play a very important role in this game. Then let us look into board. So everybody needs a board to play since it is a board game. What are the properties? The board is also initialized at the start of the game, and the board doesn't change. So it is an immutable board. There nothing changes in the board after the board is initialized. So we have a board which is of size. What is the size of the board? It can start from 0, it can end at 100 or whatever it is, and that is the size of the board. What is the size of the board? Start plus size minus 1 is the total size of the board. So since it is an immutable field, I only have getters. There are no setters. It's only the constructor we have. and it is a single argument constructor. There is no other constructors which are available. Let us look into the next, which is the snake and the ladder. Let's look into what is snake. This also snakes are also initialized at the start of the game, so there are no setters for the snake. A snake will have a head and a tail. As we looked into the uh, board, head is where we can abstract the position, head's position. Tail is where we can abstract the tail's position. So only these two fields has to be captured. How it flows we need not capture because it doesn't matter to us. Whenever a player lands on the head, the player goes back to the tail. So we need these two properties. What is the head of the snake and what is the tail of the snake? That's how we can position it. Okay, we on a board game we can decorate it like this on vertically or whatever way it is, but the player will be and the snake will start from one position and the tail ends at the other position. This is what we have to abstract it out. So what are the fields that we have? Head and a tail. Since this has to be initialized, the snake has to be kept on the board at the start of the game. It has an all argument constructor. It doesn't have a zero arguments constructor, so we will not be able to initialize a snake without a head and tail, so it becomes it doesn't hold good. So we have an all arg constructor and getters only, so we can get the head of the snake and we can get the tail of the snake. So there are no setters, which is very important when we come up with this snake and ladder game. I am repeating it again. We have to have clear getters and setters. That's going to give a clear edge towards our code, and we will not make mistakes over there. Ladder is similar to snake. If you look at this ladder, it starts from one position, it ends at other position. It starts from one position, it ends at other position. So we need a start and end. And we also have only getters and all our constructors, so we cannot initialize a ladder without a constructor, and we should be able to get the start of the ladder and end of the ladder. Similar that we should be able to get the head of the snake and the tail of the snake. These are the important parts of the game. So now let us look into the game object altogether, game class altogether. This is where all the logic goes into the snake and ladder. So a game, as you think of this game as like this, a board is as stated in the requirement. People can choose the toughness of the game. It can be it can be a board with very few snakes and very few ladders. So it will give us a edge that it is an easy game, or few snakes and more ladders, so it becomes an easy game. If we add more snakes and less ladder, it becomes a tough game. And if there are more players, we can have a bigger board. So this game is the one which decides how many snakes are there, how many ladders are there. So I have not used board in such a way that I have not defined snakes and ladders in the board. What happens if we do that? When we initialize the board only, we will keep if we get a static board like that, we will not be able to change the position of snake and ladder, and thereby we lose the ability to customize the board according to the game toughness. So I am initializing is as part of the game. These are the design options that I chose. Let us look into this way of design, and in this video I will also come up with another video where the board remains. We will have 2-3 types of boards. What happens there is, as and when we add a different complexity to the board, we need to write a new class. But here we don't need to do it, so we just initialize the board with that many snakes and that many ladders, and we need to define their start and end position. This game initializes the board with the starting and ending position. It gives an advantage, but let us look into how the other approach as well, and let us discuss the pros and cons of both approaches in two different videos. So the game contains properties such as the number of snakes and the number of ladders. So we are going to initialize this game with the number of snakes and the number of ladders. We have players. So I've used queue to have a number of players. It can be list as well, but let us look into why I have used queue in the at the later point of the video as we go through the game. But we a game will have the number of players and it is initialized at the first time, so we cannot keep adding players after the game is started. That is also we can consider as a requirement, or even we can clarify this at any point of time. Can a player come and join in between when the game is already in progress? And as we say, we are defining the game with number of snakes and ladders, and that is we have to have a container which is a collection class which says that a list of snakes and the list of ladders. And the game contains a board, and the game also knows about the dice, right? So these are the properties that we need to have at the start of the game. So how do we initialize the game? The game takes in the number of snakes, the number of ladders, and the board size. What is the size of the board? So I am initializing the number of ladders to the one which is passed and the number of snakes which is also passed. I am initializing the players as a list. I have initialized this as array deck. Deck is a double-ended queue where we can do insertion and deletion at two places, at the first start also end also. Let us, as I said, we will look into it little later why this is a queue on deck. Um, let's go with the flow. Snakes. I am initializing the snakes with the number of snakes. So I am initializing the array list with the numbers which is passed, which is the number of snakes. I am initializing ladders with the number of ladders which is passed. Now as we initialize, so we need to create a board with the size that is passed. So I am initializing the board with the board size. Okay, and then dice. I'm initializing the dice with min value 1 and max value 6, and the current value by default I am putting as 2, because at any point of time each dice faces some has some face value, right? When we keep when they keep the die on the floor, it will have some face value, so I'm just initializing into 2. So the dice, it's a cube, right? So it has values of 6. I'm initializing the board, which is very important. Now what we have done is we have only accepted the number of snakes and the number of ladders. The board should do the the game should do the random placement of snakes and ladders. So this is what is the advantage that we have. At the time of initialization of a game, we will keep the snakes and the ladders in such a position that you every time when a game is initialized, the position of the snake and ladder changes. So there will not be a deterministic so the position of the ladder and snake is not deterministic, so it is non-deterministic. This is what we told, right? When we initialize the board in prior, based on the complexities of 1 2 3, which is easy, medium and hard, so we would lose the opportunity to reinitialize the board with the snakes and ladders, because we get a similar snake and similar board at all the time. So it would become a predictable board. Now we are initializing the board at the start of the game. It becomes a non-deterministic. So here we are adding little more sophistication here, but it is just an approach that I have taken. I don't want to say this is the most efficient approach, but to me it looks like it gives an advantage. So as we initialize the snake and the ladder, I am using a set. Okay, why do I use it? Let us look into it. I have to initialize the number of snakes, right? I have to keep the snakes in the right positions. So I am using a while loop here. It's going to be a O of around n square solution, but it is okay because at the start of the game only it is getting done. So for I equal to 0, I less than number of snakes, because all the snakes has to be kept. I'm getting a snake start position, which is a snake position has to be between the start of the board and the end of the board, which is 100, or assume like 100 or 200 or whatever it is. For the simplicity sake, let us assume that we have two positions. The snakes can be kept in between two positions, between 0 and 100. Let us look into the image. A snake can be kept from this position to this position, or maximum from this position to this position, assuming that this position is the end. I would request you to follow the cursor as well. Assume like this person is standing at 0 and this is the last position where we want to reach. So this is the end position that we can take. So any snake cannot be kept uh, beyond this position, which is -1, or maximum beyond this 100. So at that point of time, winning is becomes impossible. Ideally, we should also not keep snake's head at this position, because every time when the player reaches here, they are going to come down to a next position, so the player cannot win. We can add that complexity over here, but I have not added that. Let me add that in the code later point of time. Board dot size -1. If I put that is going to get taken. That's going to be taken care. This I want to pay my courtesy to this image. This image is taken from Wikipedia. You can refer to this image from Wikipedia as well. I have just copied this image. I want to give that recognition or pointing out to them. This is not the image which I own. Okay. Uh, the snake end position, we it has to be between. So this is a random neutral, right? I'm going to get a random number where I have to keep this snake starting position. It has to be from here, and the snake end position also, which is the tail, right? You can say snake start, snake end, or snake head, snake tail, which has to be at the end. Since this is a random number, we will not be sure that whether the snake end is greater than or equal to start. If assume, like, if I am getting a number where head position is less than the tail position, it means the snake will have an inverted look, right? So that should not be a case. So let us look into it. This, if the head is going to be here and the tail is going to be the upper, so that's not how a snake is kept. So head should be greater and the tail should be in the lesser position. That's when whenever somebody hits the snake, they will come down. So when it is there, I'm going to go to the start of the while loop and reinitialize this. So it might happen till we get the right random number. So this is a complexity that we are adding here, but it is good. We ensure that all the time we ensure that the snake start position is greater than the snake's end position. And so since after this we assume that we have got a position which is head is greater than tail, I'm going to check whether we already have kept a snake in that position. For example, we are saying that a head is at this position which is like 20. I'm just an assumption, and we are having a snake's tail position which is at 10. That's also an assumption, right? We are getting this. The next time also, when the for loop hits, right, because it is generated by the system, when we are getting the same number, we should not keep a snake at the same position. So if I have to check whether the snake is kept here or not, already present uh, as part of the set that we have, because we are uniquely adding it. So if we are saying that we need to have 6 snakes or 8 snakes, we should ensure that the 6 or the 8 snakes are kept at various positions. So that is the goal here. If it is not containing, I am adding it. If it is containing, it has to go to the same while loop and it will generate a new position. So thereby we are ensuring that we are adding a snake at the right, at random positions in the board. I hope this should be clear. If it is not clear, pause this video and then go back to the position, and go back to the start of the explanation and then start watching it again. So for the simplicity, I'm repeating it again. For loop equal to 0, loop less than the number of snakes that we are getting initialized based on the complexity, I am going through a while loop. When the while loop will break, the while loop will break after we are able to successfully place a snake in a position where there is no snake which is kept, or even yeah, where there is no snake kept. So what is the condition of keeping the snake? As of now, we have added conditions like the start should be greater than end, and there is no previous snake which is present. We can add more complexity here. I will explain it here. We have a set of snakes and ladders. Okay, SL set. So we have ensured that we don't keep the snake in the same position where the ladder is kept also. That is why we have a set. So as we get an outcome of this random number pair, which is 10 comma 20, if it is the same position 10 comma 20, a ladder is there. After whenever a person comes to 10, they go to 20. When they go to 20, there will be a snake, they will come back to 10. So it will go in an infinite loop. Am I right? So we are avoiding this here. So for how can we avoid? We use a same set for snake and ladder. So we only add if the same value is not present. So thereby we are avoiding an infinite loop here. This is very important logic which you have to understand. So whatever I have explained to the snake, it is the same push logic with a little modification for ladder. Very clearly, if you watch through it, for I equal to 0, I less than number of ladders, I am adding the ladder. Okay. While true, this is the same condition. Ladder start, I'm getting a random number starting. Ladder end, I'm getting a random number for ladder end. If the ladder end is less than or equal to ladder start, here we have ensured that the snake end should be less than the start. Why? Because head is the one which brings us down, but ladder should be a vice versa case. A ladder's end should be greater than start. If the ladder end is less than start, what will happen is it cannot take us up, it will come down. So we have to generate a random number in such a way that end is greater than start. This is what we need to ensure. And if we get to that pair, I'm going to check if in the same position already a snake is there or not. If it is there, I don't keep it and I will generate new random number till we get it, and we are going to successfully place the snake and the ladder in the board. Now the game is initialized with dice which has a starting and it has a minimum value which is a maximum value. We initialize the board which has a minimum starting position and what is the end position, the winning position, and we have initialized the game with the number of snakes, number of ladders. We have kept those snakes and ladders in that appropriate position also. So the board with the appropriate complexity is ready for us to play. So once the initialization is done, then now we have to start playing. That is the next step. So board is initialized till okay. Let us go into the next step. We have initialized the board. Um, so the next method that we need to look into is add player. So as an at the start of the game, we will be able to add more players to the game. For example, 5 player, 6 player. So how a player is initialized, as we looked into, a player has a name and the player's starting position at the start of the game is 0, and the player has not won because the game has just started, the player has not won. So we have to have this add player method. Now let us look into the play game method. As we initialize the game and the board with the player and the dice, now we should start playing. So why, how do we play? And remember that I've told why I have used a queue, right? We could have initialized all the players in an array list. So let us look into why we are doing all these things as part of the play game procedure. So since it is a queue, right, whoever comes first, for example, we may add instead of queue, we might have added as a priority queue as well. So what happens at the start of the game, if 10 players are there, they may try to roll the dice twice uh, to sum up those values, and then if the value is greater, that person will get the first chance to roll the dice. Similarly, we can add complexity over there, but what am I saying is, whenever whoever comes and joins the game first will get a chance to roll the dice first. So how do we do it? We have to take the player from the queue, play it, and when the player should get the chance, they should get the chance once the last player has thrown the dice. So what is this data structure looks like? It is just looking like a queue. Let me draw it clearly. Let me put a sample here. There are 3 players, 3 4 5 6 players are there. Assume here, assume this is a queue. What happens? The first player gets a chance. He sets the position correctly, and then the next player who has to get, he has to get a and the next chance has to go to the second player. The next chance has to go to the third player. So when the first player should get a chance after the sixth player. So now what the data structure it looks like, it is a queue, right? So I have used queue here. So we should be very careful in choose the choice of the data structure, because if we use a different data structure, assume like if you are using stack, it would become very difficult for people to uh, manage the next roll of dice. So eventually queue seems to be a very appropriate data structure for a game where every player has to get equal chance, and who has to start with if you want to ensure that at the start of the game a player with the highest value should get, we can easily use a priority queue. We can always talk to through these approaches, so that we have considered everything, right? At the point of the point of design, we can always talk about all these things. If what is the complexity here? If I have to add a priority queue, you can, instead of a queue, you initialize this as a priority queue, it should be able to get. The priority queue is also a queue, but it has some priority. So whoever gets added, even if the player comes and joins at the last, and if he is going to get, or he or she is, if the player is going to get a highest value, they will come first, and as and when they roll the die, they will be able to poll the first player and then get the chance insert at the rear. So this is what I am going to do. Whenever I am whenever a chance comes, I am going to the player is going to roll the dice. We are getting the new position. What is the new position? The player's current position plus the value. What is the current position at the start of the game? The current position at the start of the game is 0 plus the value what is the player has thrown. So is it going to be enough? No, it is not going to be enough. We have to check whether the new position is going to be in the uh, head of the snake or the start of the ladder. And also we need to check whether the new position is reaching the end. If the new position is greater than end, that is given in the requirement very clearly. If the player is at position 99 and the player throws the dice, and if the player gets a value which is not 1, assume like 2 3 4 5, the player remains at the same place. That is the condition which I am handling it here. If the new position is greater than board's end, player that set position of the same position which is the old position. Now the new position is a new variable, we are not setting the new position for the player. So and then I am pushing it back here. Assuming like we the dice is thrown by a third person, so the third person gets out and he throws the dice, and he is in 99. The current value is 2. The new value is 101. So 101 is greater than 100. So the current player value still remains 99, and the player 3 will go back here. So the next fourth player will start playing. If you understand this, that is what is done in this if condition. I hope you just pause this video and then replay it. It is very important to understand this if condition. Else, assume like the player is not in 99. If the player is in 5 or 6 or whatever it is, and if the player throws another 5, or assume like the player throws 3, so the new position will become 9. The player's new position is set to 9. Okay. So can we set the player's new position to 9 immediately? No. Why? I am just using this get new position. I am iterating through all the snakes which are present in the board. Okay, and the snake's head is equal to the new position. I am saying that the snake has bit the person. Else, in that case, the snake has bit, so we have to return the new position as the tail of the snake. That is handled here. So whenever a player throws a dice and he gets a new value, and the outcome is a new value which is the current value plus the thrown dice value, we are going to go and check whether the new position is at the head of the snake. If it is the head of the snake, we return the tail of the snake. Vice versa, we are going to check with for each loop on all the ladders. So what is the complexity here? We are going to check through all the ladders n plus n, which is 2n. Is there a way that we can optimize it? We can optimize it. Let us look into the optimizations later, but we can always say that there are possible optimizations which can be done here. We can minimize the O of 2 and operations to lesser, because we can only get those ladders which are less than this number, and do optimizations here. This is not the video about optimization, but we also should be open enough in telling that, okay, assume like if thousands of player are playing snake and ladder, and every time whenever a player throws it, you are going to check for 2n position, that is going to add computational cost. We can always tell, we can always optimize it later, but this is the quick solution that I have come up with. Okay, we should be able to vocally talk through our solution. And once we get to the new position, we are setting the player's new position. And once the player's position is set, we have to check whether the player has won or not. Okay, if the player's that new position is equal to the board end value, we are saying the player has won. Okay, and once the player is won, we leave it just like that? We have to do some condition. If the players that size is less than 2, for example, if it is the last but one player, we have to break the game, otherwise we have to continue this game. That is also given as part of the requirement. If the player's position is not end, what we need to do, we have to add the player at the rear. That's what we have done. The third player goes here. Assume like fourth player has thrown, the fourth player is gone here, so that the fifth player gets the chance. This is what is done as part of the snake and ladder game. I think I've explained it very nicely. Let us run this application with a small simulation. Okay, rather than me writing test case, I will simulate it and show the outcomes of this game, so that we will be able to understand how this works. So let me walk through the main application. I'm initializing the scanner. I'm asking input for let enter the board size. So I'm accepting the board size. I'm getting the number of players. For example, we can play 3 players, 4 players, 5 players. I am accepting the number of layers. I am accepting the number of snakes. I am accepting the number of ladders. Assume like we can change this to the complexity of the game. As we said, if the complexity is 1, 2, 3, 4, 5. If the complexity is 1, we can randomly choose 2 snakes and 5 ladders. So we can have some configured settings like that, and then pre-initialize boards based on that, and render it. That gives an optimization. So we can pre-initialize 100 boards, right? And then render one of the 100 easy boards, and render one of the medium complexity boards, and render one of the hard complexity boards. So what is the memory size that we are going to use by initializing 100 boards? It will be very small, right? So it is better to talk through this optimization. Assume like if we are going to design an online board game where we need to quickly give these boards, and then probably every 2 hours we can reinitialize all the boards and then have it like that. So it would be another strategy. Assume like if you have just been asked to do the machine coding round, and this question is getting translated to a system design round, how are you going to support 100,000 players at any point of time who is going to play? Because in real time scenarios this is going to happen. So how are you going to handle this? We can come up with a quick solution. It is going to be very easy. The same code is going to work for everybody, every other situation. But what we have to say is we can pre-initialize the board and get the top board based on the complexities. For example, for every complexity, if we initialize 10 boards or 20 boards and reinitialize those boards once in 2 hours or once in 1 hour, it's going to work just like that. So it's not going to add too much complexity, and we also maintain the randomness as well, right? um, okay, let me stop explaining that here, because we have discussed enough about how do we optimize on the board initialization strategy. So we are accepting the number of ladders. So for this code, I have got the input. uh, I'm initializing the game with number of ladders, number of snakes, and number of board size. So while we initialize the game, we are initializing the array list of snakes, we are initializing the array list of ladders, we are creating a queue for number of players, and we are initializing the board with the snakes and ladders, and we are randomly placing the snakes and ladders, and we are initializing the dice as well. So everything is initialized. Now for each players, we are rolling the dice. Okay. um, No, right now what are we doing? We are getting the player name, right? We are to initialize the player. We have just accepted the number of players. We are initializing the player with the player name, and the game dot add player is done. So this all initializes the game, and then I'm going to say that play game. What play game does? Player game does rolls the player name from the player from the queue, rolls the dice for the player, and then plays it. Assume this is for a simulation exercise, right? So I am pulling it from the queue and doing it. For in a real-time scenario, instead of this simulation, we have to wait for the users to roll the dice. That is the small code change that we need to do, but otherwise the code remains the same. Let me run this and show now. Let's wait for the code to finish off. It's doing a compilation. Let it do. I will maximize this. Please keep a close watch on the console output window. Enter the board size. I'm saying 100 is the board size. Enter the number of players. I'm going to initialize with 4 players. Enter the number of snakes. I'm going to initialize with 8 snakes. Enter the number of ladders. I'm going to enter with 8 ladders, which is same. Enter the player name, which is P1. Enter the player name P2, the player name P3. So we have initialized with 4, so it should ask 4 times. It has asked 4. Okay, finally, let's walk through how many positions. I'm not going to explain too much about it, but let's see the whether it is doing in round robin. P1, P2, P3, P4, P1, P2, P3, P4. If we see, since we are using queue, it is able to it is able to do it sequentially. P1 gets first, P2 gets second, P3 gets third. So, and the ladder, right? So somehow or other, P2 has hit the ladder, and P1 has hit the snake, and P2 has again hit the ladder, and P3 has hit the ladder. Similarly, the people are hitting the snake and the ladder as well, and the new positions are getting incremented. If you see it, as they hit a ladder, their new position is going to P2's new position claim the ladder, right? So P2's position next time should be starting to 12. So the ladder is between 8 and 12, looks like. Okay. Similarly, when the snake is wet, P2's position is 13, right? So what is the next P2's position is okay. After he might have thrown 5, so there should be a snake which is bit here. So finally, who has won after so many throws on the game simulated? P2 has won. Well, all the other players, no, not P2 has won. The final player who has won is P2. Prior to that, P3 has won. Prior to that, okay, since we have 4 players, when okay, first P1 has won because no snake has bit. So long time back, P1 has won. And then who has won? P3 has won and P2 has won. So P4 is the one who is still in the loop of playing, since there is only one player which who has left. So the game stopped here. So I am able to successfully simulate the snake and ladder game. This is a very this design has to be very meticulous. We have to carefully use the constructor, we have to use carefully use the getters and setter, we have to use appropriate data structures, and this game the coding can be done in 2 to 3 hours, or maximum if you are doing it for the very first time. Otherwise, if you have a practice of doing it, you should be able to do it in 1.5 hour with all the test cases all together. This is a good question to be discussed and practiced. With this, we have come to the end of this tutorial. If you like this video, hit the like button, give thumbs up, and please do subscribe to the channel if you like these videos. Once again, thank you, and this is Bala.